So in this question, we'll be introducing the idea of three-dimensional problem. So there is a problem with this type of question because the diagram is three-dimensional. So there are 90 degree that doesn't look like 90 degree. Okay, so you got to have this awareness that because it's three-dimensional, there are 90 degree that doesn't look like a 90 degree. So we will usually look for 90 degree and make it into two-dimensional. So two-dimensional means it will just become simple triangle. Okay, and then sometimes there will be Pythagoras theorem, or there will be trigo that you will be using because of this kind of simple triangle that you manage to get up. So the idea is to visualize 90 degree that doesn't look like 90 degree. So in this question, we got a triangular prism. So they tell us that QRT is 90 degree. So apparently if this is a 90 degree, so I'm expecting this part to be a 90 degree as well. Okay, so you got to visualize it. Okay, so that means, right, this is vertical and this is actually on the ground. Okay, and on the ground, we got a rectangle sitting on the ground. So on the ground, we got a rectangle. It doesn't look like a rectangle. In fact, it looks like a parallelogram, but it is actually a rectangle. So there's also 90 degree on the ground. Okay, so there is another piece of rectangle that is like this. So this is a piece of rectangle that is inclined to a certain angle. So this piece is like a solar panel. It's also a rectangle. It is a rectangle, but it doesn't look like it because of the way it is drawn. So in a three-dimensional diagram, there's a lot of 90 degree that maybe it doesn't look like 90, or some look like 90, but in actual fact that they are not 90. Okay, so be a bit mindful on all this first, explore it first before you answer the question. So we're going to reduce to simple triangle. Sometimes a simple triangle might involve your normal trigo ratio. That means your normal Sec2 trigo can help you to do that. But sometimes maybe you might get to use your sine rule and cosine rule. Okay, so there are some questions that are like that. Okay, so let's explore the first part first. RP. So where is RP? So RP is the one that is on the ground. So take a look, RP is the one on the ground. And remember just now I mentioned, this is actually a 90 degree. Because it's a rectangle sitting on the ground. So for part A, right, I'm going to draw it this way. I'm going to draw PQ here. I'm going to draw RQ. RQ confirm will be an 8. And this is the 90 degree. That doesn't look like a 90, but like I mentioned, right, it is like a rectangle on the ground. So there is a 90 degree here. So from here, right, it's very obvious. That means you just apply your Pythagoras theorem. So RP. So I'm sure you can get it quite easily. So you will get a 17. So the next one, it will be advisable if you erase it off. But sometimes if you've got too many lines, it's actually very confusing. So try to do it in pencil. So the next one is RPT. So RPT. So RP is on the ground. So it's actually here. So this is vertical. Anything along the ground, it will form a 90 degree. So this is part B. So I'm supposed to find RPT, this part. Okay, so we will use the previous answer. So from here, I'm going to draw a separate triangle. I'm going to draw a flat triangle. A two-dimensional triangle is like a flat triangle. So this part will be PR, which I already gotten it just now, which is I got it erased. And then this is RT. RT is the vertical part, so it should be a 6. So I'm interested in RPT, this angle. So that will just be a simple situation where you do a tangent. So I'm sure you know how to punch your calculator. So always leave it in 1 dp. Okay, so I'm going to erase everything again one more time so that I can facilitate each of the part. Okay, so the next one, right, the description is V is on TU. So V is on TU in such a way that this will be equal to this. So you can guess, that means it's a 7.5 each. And then our job is to find VPQ. So where is VPQ? So VPQ is a triangle. Okay, so maybe this triangle is really not so nice. And there is no right angle in this triangle. So VPQ. Okay, so I'm supposed to find the angle, and it's not the right angle. So you need to think about your sine rule, cosine rule. So of course, you got to find these two lengths first. So these two lengths will be the same. Quite obvious because of the cutting here. Because of the cutting here, this is a 7.5. So remember, this part is also 90 degree. So you can actually do a Pythagoras theorem. But I kind of don't have this to do a Pythagoras theorem. So I got to do another Pythagoras theorem here. Okay, so can you see I got two sets of right angle, then slowly I can find the angle. Okay, so how are you going to do that? I'm going to erase this part. I will start from the red triangle. So in the red triangle, I can find UP squared. Then in the black triangle, I can find PV squared. And this is not your final answer. So you take square root. So I got the 12.5. So you can do a cosine rule for this. So put on the 12.5, put on the 12.5, and then you try to do a cosine rule. So you give it a try to see whether you can find VPQ or not. There's also another way. Another way will be I do not need to find this. I focus on finding this. Okay, so maybe for simplest. Okay, so if I'm going to find this UVP, it will be a tangent. So tangent UVP will be equal to 10 over 7.5. You can do that. Oh, I think I found the wrong angle. Okay, so sorry. Okay, I read the angle wrongly. It's VPQ, this one. So actually I can find it directly. It's like an alternate angle. So I will need the cosine rule if I wanted to find this part. So I think I look at the wrong angle, PVQ. Okay, even that, right, if let's say I want to find this, right, I can also use angle on a straight line. So this one is 53.1. This one is 53.1. Okay, so just now I saw the wrong angle. So the correct one should be VPQ, which should be this one, which I can do an alternate angle. Okay, I misread it as this one. So if it's this one, I can do a cosine rule, or I can use angle on the straight line to subtract away double of this. Okay, so that depends on which angle. So initially I read the wrong one. Okay, so I read it as the red color one, but the correct one should be the one with green color.